Okay, we have here today another really interesting integral from the Columbia Integration Bee 2022. This one was problem number 2. We have the integral of square root of x plus 1 minus square root of x over square root of x plus 1 plus square root of x dx. Okay, so I was putting this one off for quite a while just because it gets tricky in some spots and I guess I was lazy. But now I'm almost done with this integration bee, so I wanted to make sure I could finish this one. So what I'm going to do to start is I'm actually going to multiply top and bottom by the conjugate of the denominator. Now when we do this, the nice thing about this, we get a difference of squares here. Like when we multiply square root of x plus 1 times square root of x plus 1 here, we're going to get x plus 1. Then when we multiply square root of x times square root of x, we get minus x. The x's cancel, and so our denominator just becomes 1. So we get a lot of simplification right away. So we really just need to multiply out the numerator. So let's do this. So when we multiply square root of x plus 1 times square root of x plus 1, we have just x plus 1. Then for the middle terms, we're going to have minus 2 square root of x plus 1. And then multiplying the last term, we're going to get just a plus x. Now I combine this x with this x, and we can write this as 2x plus 1. And I think I'm going to separate this into its own integral, but this is so easy. I'll bring this 2 out front here. Then for this second integral, I think I'm going to multiply this together, and we're going to have x squared plus x dx. And then because, again, this is so easy, let's just integrate this and be done with it while we can. So this is going to become x squared plus x, and then we just need to deal with this thing. And I think what I'm going to do here is just complete the square on this. So what I can do is take half of, we have a coefficient of 1 here. So I can write this as x plus 1/2 squared. You multiply that out, you get x squared plus x plus a fourth. Well, we don't have the fourth, so if I subtract it off, now I haven't changed this. But actually what I want to do is take this 1/4 and I'm just going to rewrite it because I want to set up a trig substitution, so I'm going to write this as 1/2 squared. And so let's just take this and we'll put this back into our integral now. And now for our trig substitution in this form, what we want to do is we want to substitute for this right here, and it's in the form for secant. So what I'm going to do is I'm going to take this x plus 1/2, and for the substitution, I want to substitute for secant of t, but then I want to match this value here. So I'm going to put a 1/2 in front. So we're going to substitute x plus 1/2 equals half secant t. I'll take my derivative, so our dx is going to be half secant t tan t dt. Okay, so now I'm ready to make my substitution, but I'm actually just going to break out. We're just going to focus on this integral, just so I don't have to keep copying down this other junk. So when we do this substitution, just focusing on the integral, so here we're going to have half secant of t all squared minus 1/2 squared. And for our dx, I'll bring all this other stuff. I'm going to copy the 1/2 out front, and we'll have the secant of t tan t dt. But now we've set this up where we have 1/2 squared, 1/2 squared. I can take this out of the square root as a 1/2 and bring it out front. So we can change this to 1/4 and just remove this, cancel this, and write this as a 1. But secant squared minus 1 here, this is the same thing as tan squared of t. But this is inside the square root. So when I rewrite this, we'll bring it out as just tan of t multiplied by this other one. We're going to have tan squared t times secant t. But now for tan squared t, I'm just going to go and use this formula in reverse and write it as secant squared minus 1 again. So when I do that, and I distribute secant squared t minus 1 into secant t, we end up with secant cubed t minus secant t. But each of these are really well-known integrals, so I'm going to just use formulas on these. So for secant cubed t, that's the same thing as 1/2 secant t tan t plus 1/2 natural log secant t plus tan t. But the way I remember this formula for secant cubed t is this here is actually the integral of secant t. So then integrating this, we're just going to have minus natural log secant t plus tan t. But notice we have half here and minus 1 right here. So what I can actually do is just combine these together, and we can write this half minus 1. We can write this as minus 1/2 here. Now at this point, I'm ready to back substitute, but I just need a value for secant t and tan t. Of course, we're really close with secant t. What I can do is just take this formula and multiply through by 2. So we have secant of t is going to be the same thing as 2x plus 1. And then I can go ahead and draw my triangle to get my tan value. So we're going to have, the angle is going to be t, and we're going to have it as Secant is, we can write this as 2x plus 1 over 1. Secant is hypotenuse over adjacent, so we can have this for our 1 here. And then using the Pythagorean theorem for our third side, we're going to get 4x squared plus 4x. Now for our tan t value, that's just going to be opposite over adjacent. So for this value, we're just going to have square root of 4x squared plus 4x. But because there's a 4 on both terms, I can factor a 4 out and then bring it outside the radical as a 2. So I can write this as 2 square root of x squared plus x. So now we're ready to back substitute. Multiplying in the 1/4 here, we're going to have 1/8 secant times tan. So this is going to give me 2x plus 1 times our tan value, which is here, 2 times x squared plus x. Then again, distributing in the -4 here, this is going to become -1 over 8 natural log 2x plus 1 plus 2 square root of x squared plus x. And so this is going to be our value for this integral here. We just need to take this and plug it back in to finish it off. So we're going to have our first part, which is going to be x squared plus x. Now we got to remember distributing this -2, so we're going to have minus, we have 2, so we have -2 times 2 is -4 over 8, so this is going to be a -1/2 in front. 2x plus 1 square root of x squared plus x. And then for this last term, -2 times -1/8 is going to give me plus 1/4. Natural log absolute value, 2x plus 1 plus 2 square root x squared plus x, absolute value plus c. Put a plus c on there, and that's it. So it's kind of interesting because the first step was so easy, and it looked like we were going to be done in 2 seconds. And then we actually did quite a bit of work to get to this point. So we'll stop it there. Thanks everyone for watching. Have a great day.